Alright guys, here is the review for the acceleration test. The first question says, Dynamite Dragon roller coaster drops people in free fall for 40 seconds. During this time, what acceleration do people achieve? The answer is just negative 10 meters per second squared, because that's the acceleration due to gravity. Number 2, the graph below tells you what about the object's motion. It should be that the velocity is increasing, because if you look, it starts off at 0 and then gradually goes up. This means that it has a constant acceleration. Number 3, basically what you do on that one is you're looking for acceleration. So the thing you need to do is at the just pick a distance and a time. It doesn't matter which one. I picked 50 and 5. And then what we're going to do is we're going to use a formula to find the acceleration. So we're looking for the acceleration. So what we're going to do is we're looking for an equation with distance, time, initial velocity, and acceleration. So the only one with that in it is d equals 1/2 at squared plus vit. And the initial velocity is 0, so that term goes away. So we're left with 50 equals 1/2 times a times t squared, which is 5. Alright, so we end up with 50 equals 1/2 times a times 25. The way you do this is you just multiply 1/2 times 25, and so you would get 50 equals 12.5a, and then divide by 12.5, and you would get 4 meters per second squared equals acceleration. Next up on the list, number 4, if a physics student is walking towards their classroom at a speed of 2 meters per second, this is the initial velocity, when they realize that they have a distance of 30 meters to go and only 10 seconds to get to their class, distance of 30 meters, time of 10 seconds, what must their acceleration be in order to make it to class on time? So again, we got to find a formula that's got initial, distance, time, and acceleration, and that is once again d is equal to 1/2 at squared plus vit. So distance is 30 equals 1/2 times a. That's what we're looking for, so we just leave it blank. 10 squared plus 2 times 10. Notice we have an initial velocity this time, so this does not cancel out this time. This term is 2 times 10. It doesn't cancel. So we would end up getting 30 equals 1/2 times a times 100 plus 20. 30 equals 50a plus 20. Now you're just solving for a. So you subtract 20, we got, subtract 20, we've got 10 equals 50a. Divide by 50 and you get 0.2 meters per second squared equals a. Alright, next one, number 5. The car travels 25 kilometers in 1.2 hours. So first thing you got to do is get kilometers to meters. The kilo in kilometers stands for 1,000. So this is literally 25,000 meters. Okay, and then 1.2 hours, you just need to do 1.2 times 3,600 seconds to get it into seconds, and when you do that, you get 4,320 seconds. Alright, so now you do 25,000 divided by 4,320 seconds, because we're just looking for the speed, so all we have to do is v equals d over t. So we do that, and we should get 5.8 meters per second. Next one. A remote control airplane is sitting on a runway. So it's sitting on the runway, so the initial velocity is 0. The operator revs the engine to full thrust and then releases the brake. The remote control plane takes off, accelerates down the runway at 1.6 meters per second squared, and takes off with the final velocity, with a velocity of 13 meters per second. So that's the final velocity. First question, how long did it take the remote control plane to take off, and then how far down the runway did the plane travel? So the first question we're looking for time, and the second question we're looking for distance. So we're going to use a equals vf minus vi over t to find this one. So we plug it in, we get 1.6 equals 13 minus 0 over t. And we got to solve for t, so we get 1.6 equals 13 over t, multiply t up, and then we get 1.6t equals 13, divide by 1.6, 1.6, divide by 1.6, and you end up getting 8.125 meters per second, 8.125 seconds. Okay, so that's the answer to the first one. Then we're looking for distance. So then we're going to come over here and we're going to plug in d equals to find distance, 1/2 at squared plus vit. Initial velocity is 0, so that goes away. So we're left with d is equal to 1/2 times 1.6 times 8.1 squared. And if you do that, you end up getting d is equal to 52.5 meters. Alright, that's the first page done. Number 7, when a car comes to a sudden stop to avoid hitting a dog, it decelerates from -6 meters per second squared as it slows from 9 to 0 meters per second. Find the time interval of acceleration for the bus. Okay, so we need to find time, so we're going to use the A equals formula because this has final velocity, initial velocity, and acceleration. So we're going to plug it in. -6 equals 0 minus 6 over t. Whoops, sorry. Minus 9. So 0 minus 9 over t. -6 then would be equal to -9t. Multiply t up, and we would get -6t equals -9. T would then be equal to -9 over -6, which is 1.5 seconds. Alright. Number 8. Basketball player is running at 3.2 meters per second. That's the initial. Decides to accelerate for the next 4 seconds. That's the time. He speeds up at an acceleration of 0.6 meters per second squared. What is his final velocity? What is his velocity at the end of the run? So again, we're using A equals VF minus VI over T. And you're just going to plug it in. 0.6 equals, VF minus 3.2 over 4. We got to get 4 out of the bottom first. So we're going to multiply both sides by 4. 2.4 equals VF minus 3.2. Then we have to add 3.2, add 3.2, and we end up getting 5.6 meters per second for the speed. Okay? Number 9. If you are measuring a friend's reaction time and drop a ruler between their hands, just like we did in the lab, and they catch the ruler at 10 centimeters, what is their reaction time? First step is to convert this to meters. So we got 0.1 meters. That's the conversion for centimeters into meters. Next, we know the acceleration is -10 because it's in free fall. And then we know the initial velocity is 0. So we are trying to find time. So we're going to use the formula d equals 1/2 at squared plus vit. The reason we use this is because it's got time, so we've got distance, we've got acceleration, we've got initial velocity, and we're looking for time. So the time is 0, the initial velocity is 0, so that goes away. So we're left with 0.1 equals 1/2 times -10 times t squared. And do you remember why this number needs to be negative? It's because it's going down. Alright, so -0.1 equals -5 t squared. Then we're going to solve. So you're going to divide by -5, and you would get 0.02 equals t squared. Now we got a square, so we've got to square root that. And then that's when we get the answer, which is t is equal to 0.14 seconds. Alright, number 10. If a car can accelerate at 3.5 meters per second squared, what will its final velocity be after 4 seconds if it starts off with an initial velocity of 7 meters per second? So we have an initial velocity, we have the acceleration, we have the time, we're looking for final velocity. We're going to do just like we did in number 8. So we get 3.5 equals VF minus 7 over 4, which is A equals VF minus VI over T. Multiply the 4 up. Cancels that out, and we have 14 equals VF minus 7, and so then we add 7, and we get 21 equals VF. Okay? Next one, 11. If a hoverboard can start with an initial velocity of 20 meters per second and can achieve a final velocity of 80 meters per second, accelerating at 10 meters per second squared, how long would this take? Okay, so we're trying to figure out time. Again, we have A, VF, VI, and T. This means we're using the A equals formula. All right, and so we plug it in. We got 10 equals 80 minus 20 over T. So we end up getting 10 is equal to 60 over T. Multiply T up on both sides. Cancels them out there. We're left with 10T equals 60, and T would be equal to 6 seconds. Number 12. All right, this one's a little long, so stay with me. So the initial velocity is 250 meters per second, and the acceleration is negative 10 meters per second squared. Because it's going up, it's in the air though. Anytime it's in the air, the acceleration is always the same. The important thing for you to remember is that the velocity at the top here is 0. Okay, so the velocity here is 0 because it's at the top. It has to get to 0 before it can turn around and start going back down. So what we can do to answer question A, how long will it be in the air, is the first thing is we've got to figure out what the time to the top is, which is why that's here. We're going to find the time to the top. Okay, so how do we find the time to the top? Well, if we're just looking at this section here, right, if we're just looking at the section from here over, then we know the initial velocity is 250, and the final velocity at the top is 0, and we know that the acceleration is equal to negative 10. So what we can do is we can use the A equals formula, VF minus VI over T, and what we can do is solve for time to the top. So again, this is solving for time to the top. So we get negative 10 equals 0 minus 250 over T. Negative 10 equals negative 250 over T. We're going to flip the T in the negative 10, so T is equal to negative 250 over 10, or over negative 10. So the time to the top is equal to 25 seconds. Now that's the time that it takes to go from here all the way up to here. Alright? So 25 seconds is how long that would take. So how long would it take to go from here back down to here? Alright? And the answer to that is it would take the exact same amount of time. So the time down would be 25 seconds. Okay? And so what you do is the total time, the answer, is 50 seconds. It takes 25 seconds to go up and 25 seconds to go down. So the answer is 50 seconds. Okay? Moving on to B, how high will it go? Well, we can do the D equals formula now because we have the time. D equals 1/2 AT squared plus VIT. So we've got D is equal to 1/2 times negative 10 times, and I'm just going to leave T squared blank for a second, plus, remember we have an initial velocity, times time. So what time do we use? Do we use 50 seconds or do we use 25 seconds? Or 25 seconds. So we're looking at it from this point to this point, because this answers how high it goes, right? So what we want to know then is the time to the top. So we're going to use this 25 seconds. Okay, because again, we care about it to the top. If you plug in 50 here, you're going to get 0. So we're going to plug that in, and when we do, we get 3,125 meters. And that's the height that this object reached. And the last question is, what will the velocity be when it comes back down to Earth? And that's negative 250 meters per second. What speed it goes up with must be the speed it comes down with. Alrighty. Number 13. A seagull drops a clam onto some rocks in order to crack the shell. The clam falls for 2.3 seconds. We don't know anything else. The initial velocity, though, is 0 because it was dropped, and the acceleration would be negative 10 meters per second squared because it's in free fall. So question A says, how fast is it going? So we're looking for VF on A. So we're going to do A is equal to VF minus VI over T. Let's check real quick to make sure we know everything. Do we know A? Negative 10. Do we know VF? No, but that's what we're looking for. Do we know VI? It's 0. And then time is 2.3 seconds. So we're going to multiply both sides by 2.3. And then we get negative 23 meters per second equals VF. All right. For B, it says how high up was the clamshell. Well, for that one, we're going to do D equals 1/2 AT squared plus VIT. All right, again, let's check and see if we know everything. We don't know D, but that's okay because that's what we're looking for. 1/2 times -10 times 2.3 squared. And notice the initial velocity is 0, so that term drops out. So then you just plug that in, 1/2 times 10 times 2.3 squared, and you would get 26.45 meters equals the height. All right, number 14. When velocity is positive and acceleration is negative, what happens to the object's motion? So if the velocity is positive and the acceleration is negative, you're going to slow down. So to give you an example of this, this one would be like if you were in a car and your car is moving forwards and you brake, you hit the brakes. Okay? So the car is moving forward, it hits the brakes, the acceleration is negative, so the car slows down. In this case, it would be like a ball thrown in the air. If a ball is thrown up, then as it goes up, the velocity is positive, but the acceleration is negative, so the ball slows down as it goes up into the air. Number 15 is they would hit at the same time because there's no air resistance. Remember the little demonstration I did where I dropped a roll of duct tape and a piece of paper, then I crumpled the piece of paper up and dropped them, and they fell at the same rate because air resistance was no longer a factor? All things fall at the same rate as long as there's no air resistance. Number 16, the thing that you're supposed to remember is we had the photo gates and the smart timers out. We placed the photo gates at set distances from each other. So we had like 10 centimeters, 20 centimeters, 30 centimeters, 40 centimeters, and so on. And then using the photo gates and the smart timers, we were able to get really accurate times for these things. And then what you could do is, once you got that done, you could graph the distance versus time, and it should have looked something like that. Okay, a curved graph. All right. So I know this video was a little bit long, but feel free to contact me if you need anything else or you need me to clarify anything. I will be happy to do so. And I wish you the best of luck on your test.